today I'm going to talk not really about any specific creative projects. I'm going to talk about this thing that I've been making called Framelib for the last 3 to 10 years, depending on how you count. This version, no, 5 to 10 years, depending on how you count. So I'd like to start just by kind of explaining what this thing is, and then get as quickly as possible through to actually what I've done with it, some examples. So this is a kind of technical version of explaining the problem, which is basically to do with the way that audio works within Max or SuperCloud or whatever, being a continuous stream of audio that we break into convenient blocks, but they don't really mean anything. And that's okay for lots of stuff. It's okay for modeling a kind of analog type input where everything is just happening, but where there are certain kinds of processing where we want to break stuff up into discrete chunks, and the frame means something. And there are a bunch of techniques related to that, which I've kind of listed there, which are kind of well known in the literature but haven't really been adopted by creative coders. So, the thing that I've made, this is my very technical explanation, supports frame-based processing using dynamically allocated arbitrary length frames, which may vary freely in length over time or between DSP network nodes. Supports arbitrary scheduling of frames, so it's subsample accurate across the network, and you have a combination of kind of synchronous and asynchronous updating inputs at a single node, and it can resolve that. And we can get stuff in and out of our normal kind of block-based world. So obviously that's all now totally clear to you, know exactly what it does. So we'll do the TED Talk version instead. So I really hate doing granular stuff and synthesis stuff, spectral processing in Max. I've been doing it for about as long as I've been using Max, about 13, 14 years. I've done it a number of different ways. I've written externals that do specific processing. That was painful. I've done it by making stuff in Max, like granular stuff in Max in Poly, and having all kinds of weird little things that have to deal with bookkeeping issues, as I call them, that I don't really want to think about. And I've also done a granular stuff where I had a bunch of sample accurate tools that kind of made it a little bit nicer, but the patches still worked out horrible, it wasn't very efficient. So one of these problems is either not quick enough for me to do, or not quick enough for the computer doing it, it's not easy enough to do, and it's not powerful or flexible enough. One or more of those problems every time. So I had this dream that I could somehow... it's okay, I have to get the end. It doesn't really work otherwise. I had this dream that all this cutting edge stuff, I could just have it at my fingertips and use it really easily, and the world would be really, really beautiful. I'm going to do this in every... I feel great now. Right. So some characteristics to get a little bit more serious. It's a real-time thing at the moment. I'd quite like this to be a non-real-time thing. As I mentioned, essentially the idea is that we're dealing with audio in these chunks. They can happen at any time and they can be any length, and I don't want to have to care about that. It's not actually a Max thing. It's a thing that happens to run in Max, but all of the Max bit of it is actually added on at the end. And there's a PD thing that adds into PD, and I hope at some point there'll be a SuperCloud thing. And there's lots of other ways you could use it, so you can actually use it in C++. Actually, when I put a Max patch together, I can press a button and turn that back into C++ code and compile it somewhere else. So I don't really want it to be really tied to a language. For the user, in this case that means people like you, I want it to be a sort of simple representation of what's going on, quite direct. I want it to be flexible, and all of this bookkeeping stuff, these kind of problems, so Hans was talking yesterday about how do I load up this many samples, and these are problems that I just see as practical problems. They've got no musical interest whatsoever. You just have to get past them, and sometimes you know, like in the future this problem's going to disappear, but right now I have to deal with it. So I don't like dealing with those problems when I'm doing creative work, so I spent a very long time doing it, just those kinds of problems, in order to sort of not think about them later. And I want it to feel kind of native to whatever environment you're in, so the wrapping bit is quite important to get right. And I'm just going to briefly mention that it's not the first thing like this, and I'm not pretending it is. There's FTM, Gabor, and Pipo. They have slightly different focuses in terms of openness, in terms of their approach to timing here is quite different. I think that's quite important. What you can port them into in terms of different environments. and perhaps ease of use. So I don't want to spend a long time kind of bashing what they've done. I think it's really interesting, and if people are using that, that's great. But this is kind of my solution to these problems. So what's it for? A whole bunch of things. Things like that I've wanted to do for ages, like multi-resolution FFTs. What if we could do stuff with wavelets in one of these programs that wasn't just like, hey, I made a wavelet transform, and then it crashes, and then you go, but I don't know how it works or what to do with it. Really accurate and precisely timed grain stuff, thinking about grain as a unit so I can do something with it later. I'll show hopefully an example of that. Don't really want to think about voice management, maybe content-aware DSP, so we've got DSP coming in and the processing knows something about what's going on within it. And this kind of musical gesture time thing that I keep rabbiting on about. Okay, so there is a caveat. This is a long-term project in several stages. First is to design and implement the framework, that's pretty much done. Develop a core object set, that's pretty much done. So where we are at the moment, where I am at the moment, is testing and revision for consistency. I should also mention at this point James Bradbury, who is writing all of the documentation, which is wonderful, with Pierre helping him out. And so once that's all done, it'll be ready for public release. If anyone's interested in it before then, do get in touch. Then I'm going to do the really cool stuff. So there are some interesting things in, but I think some of the other things I've talked about, like wavelets or whatever, that needs more time. That's about adding objects. Then I'm going to develop my own interesting DSP usages, and then I'm going to compose some music. It's not going to happen, it's just a joke. So the really cool stuff might not be here quite yet, but I'll show you where it is at the moment. Okay, so hopefully that's enough of an introduction for us to jump into some patches, which is the fun stuff. I think that's pretty much the end of my slides. So, let me just check whether audio is on. It's not good. I just want to start with this patch, which is an example of how I'd like to write a granular synth with a relative amount of stuff. I've got just boxes to show the main bits. The blue bit's the bit that plays the sample back. There's a filter, which is just for some added goodness. I like filtering granular synthesis per voice. Then there's a window, we've got to have one of those. Then we've just got a standard kind of equal power of Hannah. At the top, I'm just generating a random number for each of the things that I want to randomize. So that's the length of the grain, the offset of the grain, the frequency of the filter, and the panning position. And then I'm just using like a single object to map it in some kind of musical way, so linear, exponential, whatever I need to do. And this is going to create from the wonderful jungly sound that we all know and love, about, I think, 300 grains overlapped at a time. That's the sound it makes. It doesn't do anything different to that until we start adding some control to it. But that's maybe an example, starting point for hopefully for a group like this of what I think that should look like. You know, of course we could try and simplify some things down like the playback, but you know, 2 or 3 objects to deal with each bit, put it together. There's no sub patches. Done.
So real quick on that one, the filter is applied per grain and it's
sorry. The filter is applied per grain and randomized per grain.
Yeah.
All of the parameters are randomized once per grain, and then that parameter is applied.
So the single objects have 300.
Nope. What's happening is that the frames travel through the single object, which is resetting each time. So it's not, in this case, there's not kind of stacking up, but there's another way that you can stack up objects to deal with what I call streams. But right now, it's just the case that you pass a chunk of audio, and within any audio block, you can pass as many chunks as you want at whatever times you want, and then they travel through the network, and then when they get to the sync at the end, we can't read any of the object names. Brilliant. Maybe I'll see it. Okay. When we get to the objects at the end, we just paste it into the audio stream.
And
No, go ahead.
the scheduler is not the one for Max.
No. So the main difference with FTM and Gabor is that FTM and Gabor, use the scheduler from Max and do everything asynchronously. In this case, what I'm doing is I'm running my own scheduler in the audio thread, and the scheduler is based upon, it's a totally distributed model actually, so all the nodes know what they're connected to, they just wait for their inputs to be ready and then they process, and they have to kind of get themselves up to date with the main audio thread. So the only requirement is that all the objects jump forward in the host environment by the same amount at a time. And in theory, the thing is able to be multi-threaded without you having to explicitly say what you want to be parallel. So if the network is parallel, in theory, it's not the case at the moment, it can be adapted to do that. I have a demo version of that, but the heuristics of dealing with that are a little bit difficult to make sure that it'll always be a win.
What it means is that you can put it in a poly, for instance.
You could have a poly of this as well, yeah.
Can I just ask? Sorry. No, finish.
Just to be very clear, what passes through each cable actually is information about each one of these grains, let's say.
Okay,
Which
so
could be
now we have to get complicated. What passes through each cable is almost nothing. What passes through each cable is a message called frame that connects up to the DSP network. Now, that's a bit complicated because actually you could say nothing.
You're not oozing anything.
No, so nothing passes. So in terms of max, I mean, I say we have to be careful because actually the cables are just pixels on the screen. But there's a different set of pointers. There's different network.
If you could make them yellow or
if I could figure out how to do that, yeah.
I'm not sure you can. Can you?
I need to ask Joshua or someone like that again because.
If you have any answer on that.
Yeah,
same for Harker.
Yeah, exactly.
Yeah, I think there are ways that I could possibly do that, and that's one of the things on my list. But yeah, so they're just like connection cables, like a jitter cable. No, so a jitter cable is like a standard max cable. Well, no, a jitter cable or a signal cable, which are all standard max cables, but they carry a particular kind of message, and then behind the scene, I build another network.
And one last question.
Yeah.
No problem with the vector size from max.
Yeah, so it is worth saying that exactly. So the issue here is that when you have a long frame that you're dealing with, you process it all within one signal vector.
Yeah.
So it is more peaky processing, which is possibly a downside, but then it enables some things that you couldn't do any other way. So there's a trade-off there. And part of my way of thinking about that is also to leverage different kinds of efficiency, so things like vectorization in the sense of multiple, single instruction, multiple data, SMID stuff, so that if those grains, because they're bigger, can be processed faster, more efficiently, which actually in the normal audio kind of small vectors are a bit too small to sometimes make that worthwhile. Hopefully the trade-off is kind of worth it. I mean at the moment, what's this running at about? 40%, I'm at 5.2, I think I could at least go down to 256, maybe I could go down to 128 on this patch. This patch is not super complicated. So we've got a little...
That's because I'm still trying to get my head around why, when you need to work this way, there's only been one or two times when I need to. So in this case, it's all just about efficiency and stuff in the background. It's nothing to do with a grain having to be one sample for any aesthetic.
No, there's no... So here, it's purely that I think this is a nicer way to work than writing the same thing in Mac. I haven't got a kind of comparison. I think I've got better at writing these sorts of things in Mac, so it is smaller than it used to be. But just the fact that I have to deal with a poly as not as a kind of necessarily an organisational unit I want.
Yeah.
Like here, I can choose to put it in a subpatch, but I can also choose not to. I'll show some examples where it really has to be done this way. As we move through. Okay, so I'm not going to talk through all of these examples in lots of detail. We'll just do a quick example of, I suppose because people have been talking about this idea of synthesis versus sampling. So here's a granular patch where I'm just generating each of the grains as noise that I put an envelope on. And I flip it either up or down so we can see output here. See that some of them are positive and some of them are negative.
It's a stupid remark. But
Yep.
You're using tilde for your objects as well.
I'm using
Tilde.
I am using tilde because they all run in the audio thread.
Okay.
So I think that's.
I was wondering if you could use something different.
Of course. They can be called whatever.
You can choose to have an underscore.
Technically speaking, I suppose they have a process. Perform routine.
They'll
some of them have
turn off the DSP.
Yeah, I
they
know
go
what
off. So for me, that made sense. But yes, I see what you mean.
What I mean is that I never know whether I can plug it into maybe a max object, a max or not. I've seen, for instance, low max, or is it low max?
From max and to max.
Oh, it's 2 max. No, it's
Yeah. So actually, well, the other thing to say is that you can't plug, you can't actually, in this system you can't plug 2 cables into one place, and like you literally in Max can't. I've made it so you can't. So I have tried to help with that kind of thing. I agree that having clearer patch cables.
No, the only thing is sync and 2 max can be plugged then to max up to MSP objects.
Some objects have audio outputs or audio inputs, but again, that's all covered in.
Can you zoom in 1 click, Alex?
Yeah.
We shot the one that makes the conversion to the.
So we can examine, like any object, what it's expecting, and it'll tell us if it takes a frame
Okay,
or a signal. So there's some work there, and I know just showing it from nowhere it's not super clear. So this is an example, I suppose, that I just wanted to show. Start thinking about this idea of my interest in kind of shape and procedure. Some of this right now isn't happening in Max, but maybe it's in Framelib, but. And I did figure out how I could code some of it in Framelib, but I didn't want to get it wrong, and it was easier. So it maybe shows how I can kind of integrate this into my normal workflow. So at the moment here, I'm just using JIT.bfg as a kind of procedural noise generator, and using it to sort of do some things that I've previously done kind of more by hand, and generate some sequence, some time series that I can map to some parameter. So in this case, I'm going to send it in as the filter frequency, and I'm also going to use it inversely to control the interval, so as the filter goes up, the grains will get faster. So I suppose this kind of is a way of starting to think about putting music together in out of very small chunks, and then thinking about longer, because I've started thinking that the real-time model is actually not the one I want. I want something where I can kind of prepare something that will happen in real time, but it's actually kind of just before real time, and then you kind of prepare some gesture or something like that, rather than making everything absolutely in the moment. And we could try some other kind of noise, simplex, maybe over a shorter time scale. Or we could play that gesture back over a longer period of time. So we get some kind of idea of this shape. So this is maybe showing, a couple of the other examples are more technical, and this is kind of musically the area that I'm exploring at the moment, but it's still at a very early stage. Yes.
I'm using the thing on the right a lot every day. Just an advice: you should use 2 of them. So like this one for the main pattern, and then a wider scale, you multiply it by another one.
Yeah. So when in my kind of gesture maker object, I have this idea of levels. And this is the problem with this kind of noise, is that everything kind of ends up. So if you have one big shape and one sort of inflection shape, I think exactly that I find more effective. But I'm still trying to figure out what's the most efficient way to be able to access lots of sounds of the type I want. This was just an experiment last night, just to sort of see how fast could I hook these 2 things up together. Maybe we'll do one more. A very small granular one. Maybe this is an example of the way that timing gets resolved. So here I have like a metro essentially, every 400 milliseconds, but sample accurate. I take a random integer between 1 and 11. I don't think it's actually, I might get 12, but it's going to be very rare. Truncate it, make sure it's an integer. Take the reciprocal of 400 and integer, and then I have another metro driven off that, so I can actually subsample modulate another thing which is also running its own timer, which is subsample accurate. And then I just play back some grain, which I'm going to actually just draw in by hand, and I'm actually only updating that grain every 1600 milliseconds, so every 4 times my main metro goes round. And all of these things just get resolved automatically for you. wanted to do some kind of demonstration of how we've definitely got sample accurate, sort of harmonic series type impulse-based generation, this would be kind of one example of that that I wrote at about 8 o'clock this morning.
Is there any kind of way of us knowing whether those different clocks are synchronized or not?
There isn't right now. I'd actually like to. There are only about 5 clocks at the moment in the thing. So about OHM1, and there are a couple of different ones that you can send an audio pulse in from your host environment. So I want something to happen now. There's one called once, which just happens at the beginning of time. So if you want to like calculate a constant or something like that, I'd quite like there to be. I think there needs to be a system for clocks that relate to one another.
Yeah.
So like subdivisions and things like that. And it's on my to-do list. I just haven't quite got to it yet. So there'll be some ways of dealing with kind of interrelated time, because the other problem is that the timing is super accurate, but if you're making assumptions that, like, I've chosen numbers where I know that they will actually line up every time, but you could have what wouldn't necessarily be a noticeable offset, but you could have some absolutely minuscule subsample offset, which would mean that you calculate twice. It's almost impossible under any system to, so if I'm dividing something by 3, and then I add 3 of them together, I might not get 1 at the end, I might get something slightly less than that. And any numeric system has that problem in a computer. So if you want clocks to be related to one another, the best way is to sort of derive them from one place.
Yeah.
So the other way would be to have like a counter, and then to count off that. So I need to figure that out, but that's the case of writing some.
Each grain has a time tag, no?
Each grain has an exact time tag, which is accurate to the exact sample plus 2 to the power of 64, so 1 over 2 to the power of 64 of that sample. So it's super accurate, it's overly accurate, but then there are some reasons for that. Yeah?
5 minutes.
5 minutes. Okay, cool. I'm not going to talk about how this patch works. This is just an example of the sort of thing that I have actually coded this up in Max before. I just wanted to show some kind of spectral process. Let's show the really crappy version first. So this is a spectral freeze. Classic sound files.
Audio.
Yeah, thanks. So that's your classic take one frame and play it back, accumulating the phases. So that's the phase vocoder. But the system that I've been kind of liking for a while is one where you examine the amplitudes and phases, the phase changes over a series of frames, and then you generate random numbers based on the mean and variation. So what that means is that bins which are jumping around in amplitude or phases which are noisy will be resynthesized in that way, and sine waves which have very consistent amplitudes, very consistent phase changes will be done in that way. So I analyze, say, 14 frames, and then I have only a 4 number per bin representation of that sound. So it's quite a low number representation. I could prepare those ahead of time and have all kinds of quite complex spectra that are frozen, and to me that sounds a lot better. Noisy sounds, we get less of that kind of harmonic repetition. If we take more frames, we can probably improve that at some point. I want to do some experiments where the frames are very close together so they're localized in time, and I kind of average the numbers from those. Okay, last example, another granular patch. So this is something that I wrote when I was in NOTAM, and I was doing some experiments to do with kind of trying to make immersive sound. Today we just have 2 speakers, unfortunately, so we'll have to kind of imagine. So this is actually representing a hemispherical dome, and what I was interested in is, let's say I've got a granular process going on. If I've got a whole grain, all that I can deal with at one time, I can analyze it, I can see what its content is, and then I can spatialize based on that. So what I'm going to do is I'm going to just start a granular process. So right now, everything's just random in terms of its spatial position. And what I'm going to do, just to make sure it's really clear, I'm going to add some filtering to that. And then I'm going to try and put an attractor in the space, which is going to attract grains that are close to a certain kind of value in terms of descriptor. So I haven't changed the way that I'm generating the sound at all. All I've done is change the way I'm spatializing it. So this green dot now represents sounds with a centroid of 1,000 hertz within a range of about 2 octaves. So if it's right on 1,000 hertz, it will be about here. If it's 2 octaves away, it will be quite far away. So what this allows me to do is kind of select some aspect of the sound and place it in. So what I was interested in doing is, I want some granular process and then I want to arrange it spatially, but I don't want to have to think about what every sound is doing. And we could use some other kind of descriptor, and we could use 2 in combination. So I'm going to turn the filtering off, probably lower this down. Let's see if we can get So we've got that kind of mid-range stuff moving around, 500 hertz. And then I'm going to do something based on the spectral flatness, so I'm going to try and get some of that kind of more acoustic guitar slaps. And this is in decibels, so I'll set it to about -20 or something like that. It's showing me at the bottom how well I'm matching, and my range needs to be a bit larger. So hopefully, yeah. I'm now able to grab that kind of transient material, move that there, and then things with a kind of 500 hertz centroid will be over here. So that was kind of maybe, this is actually probably the most advanced patch that I've actually written with the system yet. Some other people have actually used it more for creative work than me. And it's an example where, unless I had this ability to just change between representations, so again, it's sub-patched, but only in the way that I want. It could be one single patch.